Sometimes you see a model of this form: yijk mu plus alpha I plus beta j plus gij plus epsilon ijk. Here the interesting fact is that I and j, both of them are considered as fixed effects, yet the interaction term is considered random. So why is that possible? Now the reason why people will sometimes use such a model where lower order terms are fixed but their higher order terms are considered random is to come out of a problem that sometimes occurs in real life. It is like this: that suppose you have got certain machines and you want to study how they behave, and these machines operate under two types of conditions. One is their internal settings, so I will call it settings, and I have got, say, environment. As an example, you can think of this. Suppose these are washing machines and the setting will be the speed at which it will turn and the number of turns it will make, or whether it is moving in the same direction or will keep on alternating directions and things like that. An environment might be the type of laundry that you are trying to clean, the detergent that you are using, and all these things. Now suppose that there are, say, 10 settings, 10 possible values of the settings, and there are, say, to fix up ideas, there are 8 possible environments that you can have. So there are 80 possible combinations. If you really want to keep interaction effect in mind, then there are 80 possible combinations, and that is a huge number. And suppose you also want to allow replication, say k, you want to keep 1, 2, 3. So k will go from 1 to 3. For each combination you want to do it 3 times. So that will require 80 times 3, 240 runs of the machine. Now if the machine is something more expensive than just a washing machine, in that case you may not be able to afford this many different combinations. In that case, what you do is this: you make this grid. So you have these 10 by 8 thing. So I have got 10 possible settings and 8 possible environments. Instead of looking at all possible combinations, you pick some of them at random. And then you will carry out this experiment with k equal to 1, 2, 3 here. So you will take this combination and run the machines in this particular combination 3 times. Similarly here, here and here. These 4 are just chosen randomly out of all the 80 things. Then you can still use this model. You cannot, of course, use this model because some of the ij combinations have not even occurred. You can still use this model under the assumption that Gij's all behave more or less similarly. They come from some identical populations, 0, sigma, g squared, of which you have got 4 samples. Well, from 4 samples, you can have some idea about sigma g square. You cannot estimate all the gamma ij's. That is impossible. But you can have an idea about how much variation you can expect because of different setting environment combinations. So in such a situation, there is just no other way out, because interaction cannot be ignored, so you cannot work with this. You cannot afford to have all the combinations, so you cannot work with this. So either you have to abandon the entire study, or you can work with this mixed effects model. So this is often a lifesaver in real life.